All right, so for this lesson, we're going to talk about angles of elevation and depression. It's just another trig unit. The do now happens to be a Pythagorean theorem problem. If one leg of a right triangle measures 4 feet and the hypotenuse measures 7, what's the length of the other leg? We're going to call this guy x. And then you would do 4 squared plus x squared equals 7 squared. 16 plus x squared equals 49. Subtract 16 on both sides and get x equals 33. And then you have to square root both sides. So you take your calculator. I guess we'll do this to the nearest tenth. It doesn't really tell you. Come on, calculator. So if I do the square root of 33, then I get the decimal of 5.74. We might just do it at 5.7, round to the nearest tenth. So x equals 5.7. Okay. When we get into angle of elevation and depression, so the angle of elevation is going to be the angle that's formed between the horizontal and the line of sight when a tall object is being sighted. So basically, if you see this man right here, he is standing on the ground and he is looking up at an object. Well, if he looks up at an object, that's what's highlighted in yellow. But if he were to look straight across, let's say, this is what we'd be looking at in green. The man should be a little bit lower. But the angle of elevation is that angle that's formed right in between that sight line going up and that horizontal line going across. Okay, so that's the angle of elevation. The angle of depression is going the other way. The angle of depression is the angle that's formed between, again, the line of sight and the horizontal line when an object is below the viewer. So again, this man should probably be a little bit lower, but this man, if he's looking down at an object, and then he looks across from where he's just standing, the angle of depression is the angle that's in between those two particular lines. Okay, notice how that line, that angle of depression happens to fall outside of this right triangle that's being shown here. But as it turns out, this angle up here and this angle right here are alternate interior angles. Sorry about that. Sorry. So that means that these angles happen to be congruent. So the angle of depression on the outside of the triangle does turn in to what would be the angle of elevation had the person been looking up. Okay. Whenever we do trig, you need to be in degree mode, so we need to make sure that we're in degree mode. I know for sure that I am not. So I'm going to get back to my calculator. I'm going to clear this out. I'm going to go to mode. I'm going to get myself in degree and then come back out again. Okay. So we need to make sure that we can draw these pictures and we can set everything up correctly. So number one, a person out at sea spots a light at the top of a lighthouse. The angle of elevation is 50 degrees. If the lighthouse is 70 feet tall, find the distance from the foot of the lighthouse to the boat. Well, if you want to get kind of fancy, you've got a person out at sea. So here's a person, right, and they're out in the water. Obviously, they're not on the water, but they're out in the water in a boat. I don't know. And there's a lighthouse somewhere over here. Here's your lighthouse. Well, the person out at sea spots a light at the top of the lighthouse, and the angle of elevation is 50. So this person is looking up. The angle of elevation is found right here, and this is 50 degrees. Well, the lighthouse and the sea should make a right angle. You actually, in fact, have a triangle, if you think about it, a right triangle right here. We do have some more information. The lighthouse we know is 70 feet tall, so this right here is 70. It wants you to find the distance from the foot of the lighthouse to the boat. So that means we're looking for this distance right here, lighthouse to the boat. 50 degrees is the angle that we're talking about. 70 happens to be the opposite. X happens to be the adjacent. This is a tangent. This becomes then tangent of 50 equals 70 divided by x. If you make a proportion and you cross multiply and solve, really what you're doing is you're just saying x equals 70 divided by tan 50. So 70 divided by tan of 50. And then we're rounding it to the nearest tenth, and it becomes 58. Sorry. and it becomes 58.7 in this case. So x equals 58.7. This is not degrees. This is going to be feet. We're not finding an angle measure. We're finding a length of a side. Okay, let's take a look at the next one. Helicopter whose height is 1,000 feet in the air is chasing behind a stolen car. The angle of elevation from the car to the helicopter is 70 degrees. What's the direct distance from the helicopter to the car? So somewhere up here, don't mind my drawing. I don't know if that's my helicopter. I don't know. Who cares? That's crazy. But a helicopter is 1,000 feet in the air. So basically, here's the air. He's 1,000 feet in the air. There's some sort of car that he's behind. Again, I don't draw very well, don't tend to be an artist. There's his car that he's behind. The angle of elevation from the car to the helicopter, that means the car has to go up, and here's your angle of elevation. Well, what's the direct distance from the helicopter to the car? Well, that's what we don't know. That's the hypotenuse. So we've got this being our angle, this being the opposite, this being the hypotenuse. It's going to be a sine function. So the sine of 70 equals opposite over hypotenuse. Again, you can do the calculator. I'm not going to show it to you, but feel free to cross multiply and divide, and you should come out with x equals 1,064.2 feet. Let's try number 3. An airplane pilot observes the angle of depression of a point on the landing field to be 28 degrees. If the plane's altitude at this moment is 900 meters, find the distance from the pilot to the observed point on the landing field. So we basically have an airplane. Again, I don't know, whatever. It's a blimp. So we have an airplane that has an altitude of 900 meters. So here's its 900 meters. Here's the ground. Here's something that it's going to land on. Here's its landing place. We know we've got a right triangle here because the altitude and the ground make a right angle. It talks about the angle of depression. Well, there's the sight line, which means the 28 degrees happens to be right here. What you can do at this point then is say, well, wait a second. If it's 28 degrees out here, I know that alternate interior angles are congruent, which means this is going to be 28 as well. Your other choice is going to be this. This 28 degrees and this part of the triangle have to be 90 degrees because, again, it's got to make a right angle, where this guy here would be 62. You can choose to either use the 28 down on the bottom or the 62 up on the top to set up a trig function. I will do it both ways. If I use the 28, I'm going to then what am I trying to find? Find the distance from the pilot to the observed point. So we're trying to find this distance. If we use the 28, we've got our opposite, we've got our hypotenuse, and we've got a sine again. So sine of 28 equals 900 divided by x. If we use the 62 degrees, we've got adjacent and hypotenuse. And this then would be cosine of 62 equals 900 over x. Either one of these will give you the same answer. You can try it out if you don't believe me. Either one gives you the same answer, and that answer is 1917.0 meters. Got 3 more to go. From a point 200 feet away from the bottom of a flagpole, the angle of elevation to the top of the pole is 74.2. Find the height of the flagpole. I can draw flags. Woohoo! So here's our flagpole. It's on the ground. It makes a right angle. From a point 200 feet away from the bottom of the flagpole, that's going to be this piece down here. Here's the point. The angle of elevation to the top of that pole is 74.2. The angle of elevation falls right in here. Find the height of the flagpole. You're looking for this. You now have an opposite and you have an adjacent. It's a tangent function. Tangent of 74.2 over 1 equals x over 200. Cross multiply and solve, and you're going to get 706.8 feet. Again, I'm not showing you the calculator anymore. You can do that on your own. The setup is what's most important. Let's try 5. Surveyor is standing 100 meters away from a 42-meter tall building. What's the angle of elevation from the surveyor to the top of the building? So here I have a building. I don't know, again, I'm not a great drawer. Here's my surveyor. He's hanging out right here. So a surveyor is standing 100 meters away. So this guy is 100 meters away from a 42 meter tall building. What's the angle of elevation? Here we're trying to find the unknown angle. It's an inverse function. Opposite, adjacent. It's going to be a tan, but don't forget these are tan -1s. We're looking for the angle measure, equals 42 over 100. And we want all the angles, I guess, well, it says, it doesn't actually even say, does it? It doesn't. So I went to the nearest whole number. And the nearest whole number here would be 23 degrees. Let's try one more. Last but not least, from the height, 250 feet, the angle of depression from a hot air balloon to an observer on the ground is 42. Find the distance from the observer to the hot air balloon. I'm backing up for a second. I wish there's more of these examples, trying to find missing angles, and there's not, but I'm sure on the homework there is. Let's go back to this. So we've got this hot air balloon right here. And then we've got, what, some person on, from a height 250 feet. So this height's 250 feet. This is going to be the right angle. There has to be a person on the ground who's right over here. This is going to be the right triangle. It says the angle of depression. So we know the angle of depression is right here. Again, if that angle is 42, its complement angle is 48. Or you can just realize that the angle down here is also going to be 42. But you've got to show that depression angle. So find the distance from the observer to the hot air balloon. That's going to be this guy right here. I'm only going to give you one setup at this point, and I'm going to do using the 42 with my O and my H. So we're going to say that sine 42 equals 250 over x. Cross multiply and solve, and you get 376.3. That's not right. 373.6. 373.6 feet. Okay, so that's it. So the idea is to make sure that you draw your pictures, you show whether it's angle of depression or angle of elevation, label your sides, and set up your proportions, and blah, 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 blah. Good luck.